The next three topics are looking at three different equations for straight lines. So they're all equations that represent a straight line. So the first one we're starting off with here is slope-intercept form. So this is the equation y is equal to mx plus b. And let's look at what each of these letters stand for. So we have that m is the slope of the line. We have b is the y-intercept of the line. And then x and y are a coordinate point of any other point on the line. So you can input any single coordinate into those x and y values and the equation will stay true. Now, this is why it's called slope-intercept form, because we have the slope in the equation as well as the y-intercept. So let's start working with this one here. Example 1, the graph of a linear function has a slope of 3 over 5 and a y-intercept of -4. Write an equation for this function. So you'll look at this and you'll be like, cool, they gave me a slope and they gave me the y-intercept. So I am going to use slope-intercept form, which I know is y is equal to mx plus b. And yes, you'll be given a formula sheet with these formulas. So then we have slope, which is equal to m, which is 3 over 5. They gave us that. And then we have the y-intercept, which is the same thing as b in the formula, which is -4. So now all we have to do is plug everything into the formula. Y is equal to mx plus b. So then y and x are going to stay the same because those represent any coordinate on the graph. So we can just leave those as y and x. So we have y is equal to m, which is 3 over 5. The x stays the same. And then b, we're going to have plus -4. Now we can simplify this a little more by getting rid of this plus and minus sign right next to each other, because those two things just mean minus. So in the end, our final answer is going to be y is equal to 3 over 5x minus 4. So that there is the slope-intercept form or equation of this line. So now let's get to graphing these lines given the equation. So graph the linear function with this equation. So this is in slope-intercept form. We have that right here is the m value, and right here is the b value, because it would be y is equal to mx plus b. So in other words, that means the slope is 1 over 2, and the y-intercept is 3. So how we would graph this is we would plot the y-intercept first, because we know that is definitely a point on the graph. So we know our line is definitely going to go through this point right here. So y is equal to 3. And now let's do the slope from that point to get the rest of the line. So rise over run, the rise is 1 and the run is 2. So we're going to rise 1 and then run 2, 1, 2. And that would lead us right here. And we can keep doing that in order to continue our line. So we rise, run 1, run 2. We end up here, and we could keep that going to create a bigger and bigger line. We could also do, I'm just going to do this as a side note, that 1 over 2 is the exact same thing as -1 over -2, because remember those two negative signs could cancel each other out. So really we can do -1 rise and then -2 run. So we're rising and running in both the negative directions, and we could keep that going forever and ever as well. So then we're going to connect the dots, and if you have a ruler, please use one. But here is the line, and I'm going to label our equation on there. So I'm going to label it as y is equal to 1 over 2x plus 3. So there we go, we graphed that line. So in example 3, we need to write an equation to describe this function. So the equation type we're going to use is the slope-intercept form, which is y is equal to mx plus b. So we need to figure out the m value and the b value, or in other words, the slope and the y-intercept. So the y-intercept's really easy because we can just see it plotted on our graph right there. So the y-intercept is -4. So therefore, b is equal to -4. So we're already done with the b, but now we need to find the slope of this line. So what we're going to do is we're going to find another point on the line that you know the exact coordinates of. So if we're looking at our graph and our line there, we can see that this point lies on the exact coordinate of -2, -1. So I'm going to label that point as R, and I'm going to say that we have point R at -2, -1 on the graph. So now what you're going to do is you're going to determine the rise and run between point R and the y-intercept. So if we start at point R, let's see what the rise is. So we're going in the negative direction, so it'll be 1, 2, 3. So rise is -3. And then the run is going to be 1, 2 in the positive direction. So the run is 2. Therefore, the slope, which is equal to rise over run, is going to be -3 over 2, which is the m value we're looking for. So that y equals mx plus b is going to be y is equal to -3 over 2x, because we got -3 over 2 for the m, and then the b is -4, so it would be -4. So y is equal to -3 over 2x minus 4. Finally, in example 4, we have some word problems. So we're going to have to come up with an equation in slope-intercept form based on these word problems. So the student council sponsored a dance. A ticket cost $5 and the cost for the DJ was $300. Write an equation for the profit, P dollars, on the sale of T tickets. So profit is equal to income minus expenses. So whatever you get as an income, and then you subtract all your expenses, that would be your profit. So we're going to say when T tickets are sold, the income is 5T, because you get $5 for every ticket. Then the DJ costs $300, and that would be an expense. So we could write this equation as profit, P, is equal to income, which is 5 times T, because you get $5 for every ticket, minus expenses, which would be $300 for the DJ. So profit is equal to income minus expenses. Now in part B, it says, suppose 123 people bought tickets. What was the profit? So we're going to replace the T with 123 because that's how many people bought a ticket. So we have P is equal to 5T minus 300. In other words, the profit's going to be equal to 5 times 123 minus 300. 5 times 123 is equal to 615 minus 300. So the total profit is going to be $315. So let's write a concluding sentence. The profit was $315. Suppose the profit was $350. How many people bought tickets? So this time we're going to replace P with 350. So our equation, we have P is equal to 5T minus 300. So we're going to replace P with 350. And then that's going to be equal to 5T minus 300. So now we just need to isolate T and solve for it. So we're going to start by adding 300 to both sides of the equation, canceling that out. So we would have 650 is equal to 5T. And then we are going to divide by 5 on both sides of the equal sign. So 650 divided by 5 is 130. So that is equal to T. So in concluding statement, we will say 130 people bought tickets. Finally, part D, it says, could the profit be exactly $146? Justify your answer. Well, let's see. Let's plug in P is 146. So then we're going to have 146 is equal to 5T minus 300. So then we'll add 300 to both sides of the equal sign, plus 300. So then we would have 446 is equal to 5T. Now what happens when we divide by 5 on both sides of the equal sign? Well, if you're using a calculator, 446 divided by 5 is 89.2. So we'd have 89.2 is equal to T. However, that means that 89.2 tickets were sold, but that's not possible. How can you sell 0.2 of a ticket? So I'm going to say you can't sell 89.2 tickets. It must be a whole number. Therefore, so I'm using my 3 triangles for the therefore symbol, profit cannot be $146.